Okay. Right, so that's what he was getting to earlier.
All right, guys, let me catch up to you a little bit. If you're not done with the bottom, don't worry. Let's see, 24 and 11, right? So multiply and add. So the first one should have been pretty straightforward. There's not too many ways to break 24 up. So 8 and 3, I like it. We do this differently. Multiply, add. So 8 and 3. Multiply to be negative 40. Add to be 6. What'd you guys get there?
10 and negative 4.
So I really want this, now listen. You ready? If they multiply to be a negative number, that means they have to have different signs. Which means when you add them, you're actually subtracting them. Does that make sense? You guys kind of with me? Hopefully that makes sense. If they're different signs, when you combine them, you're actually subtracting them because one of them is freaking negative. So then forget the negative for a second. What two numbers subtract to be 6? You know, like 9 and 3, but that multiplies to be 27. 10 and 4, that makes 4. So 10 and 4, now you just put the negative in the right place. It's supposed to add to be positive, so the bigger one better be positive. So put the negative there. Right, so there are ways around the negatives always giving us trouble. You can't always get around that though, it just does. What's this one? Oh, anytime that they add to be some kind of 1, that means they have to be 1 apart. So that makes this easier to break up. So they have to be 1 apart, so it's got to be what?
8 and 7.
8 and 7. They got to add to be negative, so the bigger one has to be negative. Bam. I like it. So again, this skill I could teach anywhere, almost any level. It's just a question of getting used to playing with some numbers. And how does this apply to what we're about to do? That's this motivation. You got to love that shit. Motivation stuff.
I noticed the title of that and chuckled to myself.
Yeah. So our motivation for factoring should be to start with multiplying shit out and seeing what happens. If I multiply some stuff out and I go, what just happened? What just happened? Maybe I can make a process that will work to go backwards. That's the whole idea. So if you do x plus 4, x plus 5, what'd you guys end up with?
X cubed.
2,
9x plus 1.
Plus
20.
20. Right? Is that cool? I mean, that's where you should have gotten. X squared plus 4x plus 5x is 9x plus 20. 9 is 4 plus 5. 20 is 4 times 5. 4 and 5 multiply to be 20 and add to be 9. Holy shit. Right? That's why. So that's going to be part of the backwards process we're going to use. Because notice this, if I give you this and I say factor it, now I know it came from this times this. What has to go first? Well, x and x make x squared, right? So the whole problem, the whole factor idea, bless you, becomes what numbers go here to make both of these things work. That's why this was discussed, right? So they have to multiply to be 20, so it could be 10 and 2, but then they have to add to be 9. Holy shit, it can't be 10 and 2, it's got to be 4 and 5. So then 4 and 5. That's going backwards. All right. So when I say multiply or simplify, you would never factor because factoring is the opposite of that. Factoring is undoing multiplication. And if you do a few more, you start to see the pattern still holds. This is part A. Part B, x plus 2x plus 8. You end up with x squared. 2x and 8x is 10x. 16. And of course, 16 is 2 times 8. 10 is 2 plus 8. Reinforcing that thought that we have, that maybe that'll be the pattern that I can use to make a process. C, just to go quickly, you should have gotten x squared minus 8x plus 12. And then D, not even to write it down, you should have gotten x squared plus 3x minus 28. And again, 3 is 7 plus negative 4, and negative 28 is 7 times negative 4. So now we say, okay, So the whole idea of the middle stuff was just to make sure you notice that. So now if I said, factor x squared plus, what you got, Jeff? 11x plus 30. You would say, I know what goes first. I know that's totally known. It's freaking x squared. The only way to make that is x times x. Okay, that part I got down. So then the whole problem becomes, what numbers make the rest of it work? And what numbers multiply to be 30 and add to be 11? Yeah, 6 and 5, or 5 and 6. It doesn't matter, right? I mean, it's multiplication. And to check yourself, you get x squared. I knew that was going to work. Plus 6 plus 5 is plus 11. And of course, 6 times 5, 30. Now again, if I made that 31, this doesn't go anywhere, right? So there are going to be some problems that are prime. There are not going to be a lot of them that are prime. So don't just start going prime. I don't see prime. I don't see how that one works. Prime. No. There might be a few that are prime. Don't go crazy with prime. So, I don't know how many of you guys got to try out some of the bottom part? Yes?
For the language, this is simplify.
No,
Take it
no.
back apart.
This
I wanna
is
make sure.
factoring.
Okay, that's the part. Okay.
This that is simplify. Simplify means do the operations. What's the operation in this problem? Times. Simplify means do the operations. Factor means undo the multiplication. It's the exact opposite. But once you learn how to factor, you start doing it like everywhere.
So yesterday we just divided.
Say again?
So yesterday we divided.
Yeah, we tore them apart more directly by just straight up dividing something out. I like it. Here, there's nothing common to all three, so I have to do a little bit more complicated method now to break it up. I can't take something out of all three of these, can I? But it's still factorable by doing this new process we've learned. So let's see. So I need two numbers that multiply to be 12 and add to be 8. 6 and 2. And those are the numbers, I know x and x. As long as this is 1x squared, that's going to be x and x. And then I use the whole skill building thing we did to figure out what numbers go at the end. So I'm always curious. It's always like it's at the same time it's really hard and it's also too easy to believe. Those are both going on at the same time, I think.
Where do you get the answer?
Well, yeah, but I don't know what's really going on in your head, to be honest. Unfortunately for me. And again, if I just picked any value of x, this would be a number, and this would be one way to factor that number, right? So just to show you again, in blue is stuff you'll never have to do. If x was, doesn't matter, if x was 2, this would be,
Oh, so
if x was 2, 2 squared is 4. 8 times 2?
16.
Plus 12. 4 plus 16 is 20, plus 12 is 32, right?
Right.
That number would be 32 if x was 2. What would this number be if x was 2? 4. And what would this number be?
8.
Is that a way to factor 32? Yes. So every number that I would get from this is a way to factor it. Right? That's what that means. So the blue stuff is extra stuff you never have to do, but it's the concrete stuff you can hold on to. That's what we actually just did. So part B, notice the middle term is negative.
Jeff,
Yes.
I think there might be either a typo or I might be going crazy. Because
Part F, yeah.
in here,
Yes.
it says that they have to add to be 12 and then multiply to be 7. Inside the middle part.
Oh, yeah, that should be turned
What
around.
I'm tripping
Thank
on.
you, that.
I was like,
Yeah, don't trip out too hard.
So
Cross out
F-
the 12, put a
F-
7. Those
is
are
F
turned
wrong?
around. Huh?
Is F wrong?
No, it's not. Because, again, can you factor every number? No. So some of the expressions that we get will be prime. There are no numbers that multiply to be 7 and add to be 3, right?
Yeah.
or not any nice numbers. Let me say it like that. Because there are numbers, but they ain't nice. They're kind of gross. Yes?
So what's the typo?
Sorry. So in the little middle part, it should say, given something like x squared plus 7x plus 12, we find two numbers that add to be 7 and multiply to be 12. I don't know why I decided to turn this around.
Yeah.
Thanks, Shane.
Oh,
Same way.
that sounds like the fetus too.
Well, then say so.
That never makes sense. So.
Now here, notice they have to multiply to be positive. So what does that mean about the two numbers? Can they be different signs? They have to be the same sign. They have to add to be negative, so they both have to be. They have to be the same sign. That's the only way they can multiply to be positive, right? If they were different signs, they would multiply to be negative. So they both have to be negative. Okay, so that people often look at the negatives as being extra shit to take care of, but they're actually trying to help you if you let that happen. So what multiplies to be 20 adds to be 12?
And negative 10 and negative 2.
Yeah, 10 and 2, and they both have to be negative. So then this factors to be x minus 10, x minus 2, or x minus 2, x minus 10. It don't matter. 4 times 7 is the same as 7 times 4. Doesn't matter what order you put those in. Let's see. Oh, this one I actually did earlier, if you remember. I didn't do the factoring, but we did the numbers. So we actually did two numbers that multiply to be negative 60 and add to be negative 11. If you look at your notes. Yeah, negative 15 and 4. So minus 15 plus 4. And now what about part D?
Did you pull out of 2?
Yeah, what do you always try first? You always try GCF, and I was sort of not even doing it because it was obvious nothing come out of everything. But we haven't talked about what to do if this first number is not a 1. It's actually got to change things a bit. If that first number is not a 1, it influences the middle shit because they're going to FOIL it, right? They're all going to. So I've got to take that into account. We're going to learn that one next. But right now, good Lord, we have no idea, but thankfully that 2 just gets the hell out of the way. So I'm left with so now I need two numbers that multiply to be 4 and add to be 4.
2.
2 and 2, I like it. So it'll be 2 xx plus 2 plus 2. And of course you could if you wanted to. If you stop there, you're fine. But you could also write this as 2 times x plus 2 squared. Nothing different there. So just, yeah.
I'm sorry, where did the 4 come from? Like,
So the very first thing I did was notice that a 2 can come out of everything.
okay.
So we did GCF. Yeah. So in this case, GCF saved my ass because I don't know what to do. There's a number that's not 1 there. We haven't talked about that yet. So thank God that number gets out of the way. And now there's a 1 there, and now I know what to do. So as long as there's a 1 there, it's just finding the two numbers that make these work, and you're done. If there's not a 1 there, oh shit, there's a few more steps we got to do. Yes?
I multiplied the first, the 2 times 8.
Yes, so you might know the process, but not everybody. We haven't talked about that process yet. So that's what you would do if I couldn't take it out of the way. It'll still work. At the end, you should add a 2 you could take out of somewhere, right?
Yeah, I got 2x plus 4
Times x plus 2.
and then x plus 4.
And then you can take a 2 out of that, and you end up in the same place. I love it.
But is it the same answer if I leave it like that? Like,
Well, the thing is, if you left it like that, it's like me asking you to factor 30 completely, and you say, well, it's 3 times 10. Why would I take points off? Because this can go further. So that 2x plus 4,
it's not simple.
it can go further, yeah. Cool. All right. If you haven't tried part E yet, try it out real quick. little hint, it's sort of related to the very first C up there. You got it.
Think I do.
Oh, just take a 2 out.
Just for me.
Because if you have 2x plus 4, can't you take a 2 out?
Okay, I was looking at those terms.
So see, like right there, I could break 10 up, I could take a 2 out of 10.
Oh,
The 3 should sit in there. Yeah. Same thing happens there. So you'll start noticing some threads, some common threads. When that middle number is a 1 of some kind, this has got to be factors that are 1 apart. So they end up with a 1, right?
Right.
So it kind of makes it a little bit quicker. Yeah, so this has got to be what?
9 and 8.
9 and 8. It's got to come out to be negative, so which one's negative?
9.
None. So a minus 9, a plus 8. If it would have been this instead, what would it have been?
Plus 9 another 3.
Yeah, plus 9 minus 8, because now the bigger one's got to be positive to make the middle term come out right. I like it, I like it. Some of you guys are like, well, that's good for you, Jeff. And again, factoring is a basic skill. It's like a beginning point. And then when you learn factoring, you start to see what does factoring do for you. And if you went very much further in math at all, eventually you get to a point where you're like, how did I do any damn thing before I knew how to factor? You guys are like, I don't trust you, Jeff, but I understand. And of course we already talked about part F. There are no factors of 7 that make 3. Not whole number factors of 7. These are all about whole numbers that I'm trying to do here. So let me do something that's still based on what we just did and see if you guys get this. So what if I had this? Can somebody tell me what's kind of missing from this? And if you know how to do this, maybe just sit there for a second. Compared to this, there's 3 terms here, right? What's missing there? Which term is
The
missing?
middle term.
The middle term. So, you don't. It's a little bit of a preview, but I want you to see. Well, we'll see. So really, what's in the middle is 0 x's. Does that make any sense at all? Eventually, I'm going to want us to not write that at all. In fact, I never want you to really write this. But so it's got to be 2 numbers that multiply to be negative 25 and add to be 0. So they have to be opposites of each other. So it's got to be 5 and negative 5. So the only kind of number that would work here then, what other number would work here? 25 work because 25 is 5 times 5. So if I make one of those negative, they can cancel. 26 wouldn't work here worth anything. Because what times itself is 27? Oh, shit. So what number would work here? What other number would work here? You could do it. 5 times 5 works here. So would 6 times 6. 36 would work here. 49 would work here. 9 would work here. 4 would work. All the squares. Because then I can break them up as a number times itself. Make one of them negative. So they would cancel. So this would be x to make x squared. Minus 5 plus 5. And then they cancel, don't they? See, the middle term cancels. So we treat this as a different form of factoring, and the reason we do that is because we can make a shortcut method. Right? So the shortcut method would be, if I've got like y squared minus 49, these are both squares, so then I could just put half of them in each of these. There's two y's and there's 2 7s. So you put a y there and a y there, a 7 there and a 7 there, and now make a plus minus. So it's built on the same thing, the same thought process for this kind of problem, but then I can make a shortcut for it. Because it's got to be the same numbers to make the middle term go away.
So whatever the square is, you put it.
Yeah, whatever number is, or letters being squared, I just put one of each. So I put one of each in each little dude. So if I had, for example, m squared minus 81, what would that be? So what did I put here? An m and an m, and they make two m's together, right? M squared. Minus plus 9 and 9. And that makes my 81, and why am I not worried about the middle? Because negative 9 and 9 are going to cancel. That's built in. So this is called a difference of squares, yeah. We're all creative people as math people. Let's go squares in the mind. Okay, so just a little preview of what we're going to get into next. In fact, let's redo this motivation real quick. So if I had something, now let me see if I can write this down and not freak too many people out. If I had something in this form. So we've seen stuff like this, right? That's what we've been focusing on today, where the first number was a 1. And the one that had a 2 in the front, we got it the hell out of the way quick. But what if there's a problem where there's a number here that won't factor out? There's got to still be a process that I could try. And there is, thank God. So let me see, so for example, 4x squared minus 5x minus 6 will factor. It will factor. And there's a method called trial and error where you just try some shit until you get it to work. Which is a valid method, sort of, but it's the method I want to stay away from a little bit. Right? You just keep on throwing shit at it until you, oh, that worked, yay, I'll stop and go to the next problem. Sometimes that'll take forever because it's a weird answer. So for motivation, where would something like that come from? It couldn't come from this, for example, right? It couldn't come from that. What do I have to add in there to make something, so the first number's not a 1, I have to put like a 4 here or something, right? Mm-hmm. All right, and now, go with me for a second. All right, and you're all like, that's all we ever do now. I really want that to make sense. This is motivation for what we did earlier, because there's a 1 out front. Now I've got to put a different number there and investigate. I'm going to do the same thing we did earlier in that handout. What happens when I multiply things so I can figure out, is there a way to go backwards? So let's see, we get 4x squared. That's nice. Then I get plus 3x. 28x. The first thing to realize is that my middle term is no longer this plus this. Right? It's not 7, it's not 10, it's freaking 31. Why is it not 10? Because that stupid 4 screwed with this 7 and messed up the whole middle term. Ah, shit. So we cannot do, if this was the problem, we can't go, what factor to 21 had to be 31. That wouldn't work. Because actually it should have been a 10, but this stupid 4 messed it up. Damn you. So, watch this. Let me see you guys. What is 4 times 21? The first number times the last number. This is what Maddie was talking about a minute ago. What is 4 times 21? 84. And 84 divided by 3 is what? 84 divided by 3.
It's 20, 30, 30, whatever.
28.
And if you don't trust me, you can do it in the calculator. All right, now let's do another one. This is the last little bit we're going to do today. I'm trying to modify my process, and you're all like, okay, whatever. But this is how math works. We do some stuff, we see, was there something that will always kind of happen that way, and can we make a process to always make it work? That's what math tries to do. And then the real math is like tweaking that when it's not perfect, because the real world's not perfect. So let's do another one. So this number actually came from factors of this times this. Not just this by itself, but this times this. So let's see if that happens again. So, sure. So what do I get here? 6x squared, 21x. So you get 6x squared plus 11x minus 35. Gross. Right? So, what is 6 times negative 35? 6 times 30 is? 6 times 3 is?
Negative 2.
Yeah, negative 210. Okay, so 6 times 35 is negative 210. And what is 21 times negative 10? Well, it's negative 210, of course. You just throw a 0 in the end, right? I guess.
Okay, yeah.
So we're starting to see a process. So the process seems to be, if I give you something, let me go back to the one I just had a second ago. 4x squared minus 5x minus 6. The first number is not a 1. I've got to take it into account. So I don't find factors of negative 6 to add to be negative 5. I find factors of negative 24. You take the 4 into account because it gets mixed up in there and messes things up. So I've got to take it into account in the first place. So what multiplies to be negative 24 and adds to be negative 5?
Sorry, repeat the question.
Multiplies to negative 24,
8 and 3.
8 and 3. And which one's negative?
Good.
The bigger one, I like it. Now watch, here's the process. Notice, if I just look at this exactly backwards, what does it look like I did? I took 11, and I broke it up into 21 minus 10. Right? Here, took 31, and I did this, and I can break it up into 3 and 28. And then how many terms are right here? How many terms are there? 4, so I could use grouping. Right? I love you guys right now. We'll try to absorb everything. But so what I do, I take these numbers tell me, now this is what I said earlier, these numbers tell me how to break the middle term up to make 4 terms. Why is 4 terms so cool? Because grouping should be relatively easy. It's just a couple of GCFs, right? So this is what I was saying earlier about a choice. I could put the 3 first and the negative 8 second, but I want a positive sign in the middle like we were talking about earlier. So I'm going to do 4x squared minus 8x plus 3x. So what I've done is I've taken this 3-term disgusting thing and made it a 4-term dude that'll work. So, right, there's 4 terms now. I can just group this. Now, there's a billion different ways. There's a billion to the billionth power. There's an infinite number of ways I can make negative 5 break up. Is it negative 5, negative 2, and negative 3? Isn't it 10 minus 5? Negative 10 plus 5? Isn't it negative 20 plus 15? There's a billion different ways to write 2 numbers here that add to be negative 5. Does that make sense? I could have made it negative 6x and 1x. That would have made still negative 5x, right? But that grouping wouldn't work. This gives me the only 2 numbers that will make the grouping work. That's this process. And on the paper, I call it the same thing it was called when I was taught this way, surefire method. Surefire, well, just deal with it.
So with the negative 210, it has to...
Yeah, so here, to think backwards, if I was given this problem, the first step is multiply this times this, negative 210. I need factors of negative 210 that add to be negative 35. I'm sorry, that add to be, where am I at?
11.
Factors of negative 210 that add to be 11. And that would be 21 and negative 10. So I would break the middle term up, and then I would group this and end up here. So let's try, how do I group this? What comes out of this first group? 4x. X minus 2. 3. X minus 2. So then I get x minus 2. 4x plus 3. So you get minus 8 plus 3. It's minus 5. Right? I get my 4x squared, and I get my minus 6. Ooh, I know, I could feel it in the air and you're like, that sounds great. But hopefully it made a tiny little bit of sense. It's not just, well, this is the way we decided to do it. It's, that's the freaking way it actually happens. That's what happens. So here, before I let you out, let me let you try one on your own.
Is it 210 probably done?
Remember, this one was motivation. I started with the answer, right? Just to get an idea of what actually happens. So then I can try to do things backwards, right?
I see what you did there.
I like it. Thank God. It doesn't always happen. All right, so what about, we make one that actually works. That'd probably be a good idea, Jeff. You might be able to see how I make something that works. Yeah. There you have making stuff up on the fly. Let's see. This does work.
You see these hands method.
Well, you're still going. Cool. Make sure you guys are on the right track here. Where are you at? So in case you've done this before, I mean, this is where some students, some teachers do this called master prime. I have no idea. I don't know the alchemy behind why this makes it better for some students, because it's the same work, but somehow they feel like this is magic. So if you've done this before and you like this, great. I don't care. It's the same work. So this just means I got to multiply to be this and add to be this. Right? It's the same thing I'm thinking about over there, but if this makes it easier somehow just to write the numbers like that, great. So what did you guys get for the numbers here?
Negative 10 and 4.
Yeah, 10 and 4, and then the bigger one's got to be negative. I like it. So the thing to try to stay away from is, since there's an 8 out front, this is going to be a little bit longer process. I can't just throw those in and be done like before. That was easier because there was just a 1 out front. There was less unknown shit. So don't say this is the answer. This is just how you break up the middle. So I'm going to do 8x squared. I could do plus 4x minus 10x. But again, like we said earlier, if I got a choice, I'm going to put the positive one in the middle. So I'm going to do minus 10x plus 4x. Notice also, another mistake is people just put the 10 and the 4 there. But they have to add to be this. Right? So you have to have the x's on them so you actually get the x there. I like it. So negative 10x plus 4x is negative 6x. So did I just actually change anything? No. It's like going 2 is 1 plus 1. Oh my God. No, so it's a negative 6 is that. That's amazing. But now that I've written it in the form with 4 terms, I'm allowed to use grouping. Now this might be where people had a little trouble. I like this because this didn't happen yet. So I wanted to make sure this would happen. So if something a little bit weird happens, what comes out of these two? 2x.
And then 4x minus 5.
Now watch. If I said factor 7, the only way you can factor 7 is 1 times 7. So I'm trying to factor this. Nothing comes out, so I can factor it as 1 times this. And now it looks a little bit more like what we're used to. Then you won't make some simple mistake. There's actually a 1 here. So what's the last step? What can I take out? 4x minus 5. And then what's in here is going to be,
2x plus 1.
if you don't do this for yourself, you might forget this dude and get the wrong answer. It's like that placeholder guy that we talked about before. And how do you check yourself? You just FOIL this back out. That should be relatively quick, so you can always check yourself at the end.
So when you write those numbers, you write them next to an x, right?
Here, yes, exactly. So this process is just finding the coefficients. I'm just focusing on the numbers that make it work, and you just got to make sure to actually include the whatever that variable is. Yeah. All right.
I got it right.
Got you sleepy, but not asleep. That's good. So that's enough for today. I think. So that's happened before. That's happened to me before with an instructor came to evaluate me, and he was sitting in the back, and he just started snoring.